Okay, hi guys. This is the Junior Certificate 2013, Paper 1. It's a bit of algebra here. It's question 3C, part 1. It says, given that a squared equals bc squared plus a plus c over b, show that b equals 1 over a minus c. And what they're actually asking us to do here is to isolate this term b. Is that okay? So I'm going to put b in a little box to remind me. I'm going to set about isolating b as we work through this. Now, first move, I'm going to just write the question down. So a squared equals bc squared plus a plus b plus c, I beg your pardon, over b. Now, this side is a fraction. I'm going to make this side into a fraction also. So I'm going to put it over 1 to make it into a fraction. Now, my objective is to eliminate the fractions. And you might say, why am I turning into fractions? If I have it ordered on both sides, I can then cancel out the fractions. My next move is to bracket the tops, like so. And my next move is to find a common denominator between 1 and b. And the common denominator of 1 and b is easily figured out. You simply multiply them together. And 1 multiplied by b is b. So my common denominator of the two bases is b. And I will multiply this by both of the tops of the fractions, like so. So I put a b here and a b here. Is that okay? b multiplied by a squared is ba squared over 1. b multiplied by bc squared, b by b is b squared, and the c squared is already there. b by a is ba, and b by c is bc. And on the bottom we still have our b. Now for the next stage, we want to kind of eliminate these fractions if we can. And a fraction means the top divided by the bottom. So ba squared divided by 1 is ba squared. bc squared divided by b. Now b squared means there's two b's here. So b squared divided by b would be b. And c squared stays multiplied to that. ba divided by b is just a. And bc divided by b is b. So we've now eliminated our fractions and it's starting to take shape here. My next move now is I would like the b's on the same side of the equal sign, or the equation. So what I will do is I will subtract bc squared from both sides. And when observing equation in algebra, whatever you do to one side of the equation, you must do to the other. Therefore, I've subtracted bc squared from both sides. So we now have ba squared minus bc squared. bc squared, take away that, is just 0, so it's gone, is equal to a plus c. Now, I have two b's here, and I would like to have one b. Therefore, I'm going to factorise b out. So, to factorise it, I must divide it into both terms and open a bracket. ba squared divided by b is just a squared, and that will be in a bracket here. And minus bc squared divided by b is minus c squared, and that will equal a plus c. So we're doing really well here now. Now we need to observe that we would like to isolate it, and at the moment it's multiplied by bracket a squared minus c squared, and it's multiplied because it's adjacent to that bracket. Now to isolate b, I must divide both sides by a squared minus c squared, and I'm going to divide this side by a squared minus c squared. And a squared minus c squared divided by itself is just 1. And as b was originally multiplied by this, it's going to be b multiplied by 1, which is just b. So we've succeeded in isolating b. And we have a plus c over a squared minus c squared. Now, we need to simplify this as much as we can. The top line I cannot do much with, but the bottom line, you might have spotted, is a difference of two squares. So I'm going to factorise this. And to factorise it, I'm going to write two little brackets squared, subtracted. A squared goes in here because a squared is equal to a squared. And what will go in here? C, because c squared is c squared. I then write two brackets adjacent to each other. A squared is first, so I'm going to put a here, and I'll put the second a in here. C squared is second, therefore the first c here and the second one here. And the two signs must be different, hence it's a difference of two squares. So I put a plus here and a minus here. And this I will substitute in for the base. So I get b equals a plus c over a plus c bracket a minus c. And you can see a plus c divided by a plus c, they divide in nicely. You're left with 1, and we are left with what they originally asked us to do. They asked us to show that b was equal to 1 over a minus c, and we have done that. And that is the question completed.